Hello, everybody, and welcome. I'm glad you're here. We're going to be talking about the robot. I thought, let's see here. This is the American black bear cub, Shenandoah. I guess that's Virginia. But he has the same look on his face that I have when we are going to talk about this topic. And this is inside of Keyshot, which is a rendering program. Um, Again, welcome. I'm glad you're here. I have a YouTube channel named Patrick Gray, and I invite you to subscribe. There's all sorts of stuff there. I think you'll enjoy it. I do have, and I am showing this inside of Keyshot, and it renders it with the graphical. I have an NVIDIA card. I do have a website. The name of the website is Pistonrobot, and it has a menu. You can go to the menu, and this is discussions about the robot. Here is some of the topics that I've been talking about. Inside of this is some more on this walking. Here's an example of give the robot a hand. And of course, I always try to remind everybody anything that's physically real might hurt somebody. So if you can't take something you created as real and keep it under control in a manner where it is under control in a legal and reasonable and safe fashion, then my suggestion is don't create it. And we're going to talk about hydraulics as the prime mover. I use the word prime mover. In my feeling, prime mover is the thing inside the robot that makes everything move. So all sorts of stuff might be moving, but there's something in there that is taking energy and using that a conversion process so that that energy allows something to move. A lot of the robots use what I call a rotary encoder, which is basically an electric motor that spins around. Its shaft of the motor spins in circles and it's geared down. But there's another type of prime mover, which is a hydraulic cylinder, where the hydraulic fluid under pressure goes in and out of the cylinder and pushes the piston either so that the piston and the piston rod are retract up into the hydraulic cylinder or extend away from it. And I'm talking about hydraulics. And again, you can see it's rendering it, but this is the piston robot. And the truth is, if you look at a hydraulic cylinder, it's got a connection point. It's got the cylinder itself. Inside the cylinder is the piston head, and the piston head is connected to a piston rod. And when you put pressurized fluid in here, this rod either extends or retracts. And this whole entire structure is called a hydraulic cylinder in the world of mechanical engineering. It's my opinion that most people would consider this to be a piston. So that's why I named the robot Pistonrobot, and why I named my website www.pistonrobot.com. And you will notice that the robots don't have any arms. And I did make arms, but that was later. I'll show you those. Now, what happens, even though I got the graphical processing unit from NVIDIA, these drawings get complex enough that the system has a little trouble rendering it. I mean, we do have a shoulder, and I'll show you that. All right, and here is a view of the robot shoulder. Sometimes I lower the number of parts that are in it because it's easier to work with. But again, the human shoulder, it can do abduction and adduction, and it can do flexion and extension, and it can do internal rotation and external rotation around the humerus. And all of that is in here, but it's a complex drawing. And I'll show you a different view of it. And this is a view that I created showing how the robot can move its arm up and down, and it can move it in this way and out that way. And it can actually swing its arm behind itself. All of these are drawn in a three-dimensional drawing program, and I can actually export them to FBX, and you can open them in your own 3D drawing program if you want to. Each one of these is probably 40 minutes of time to export. I don't mind doing it if anybody wants it. I mean, because you could look at this inside your own 3D drawing program. I did export it and get it into Autodesk Maya, and that seems to work. But we're going to talk about walking, and so I'm going to go back to the robot that doesn't have any arms because it's simpler. And I think one thing we need to mention is that walking is a cyclic activity. So I split walking along into, what did I split it into? It looks like 21 poses. But wherever you are, like here, what is right in front of this particular pose is that pose. And whenever you want to talk about a cycle, you have to start somewhere. And so that's important to understand. It doesn't really include, I could be in a stable position, but it's not because it's walking. And what I wanted to demonstrate is what can you do with a hydraulic approach to a bipedal, balanced, human mimicking walking robot. And I guess that a rotary encoder could do this, but it clearly can do it with a hydraulic system because you're looking at an image of it doing that. And that's what I wanted to show you. And one of the things I wanted to mention is that, you know, the human being at least has been on the planet for 200,000 years and maybe 2 million years. And independent of going back to the beginning of time on the topic of evolution, it doesn't matter. In the last 200,000 years of human beings on the planet Earth, they have been optimized the whole time. That's just going to happen. There's no way for that to not happen. We've been creating humanoid robots for like 14 years. So you're looking at 200,000 years of optimization versus 14 years of optimization. And in my opinion, the human form and all of the parts of the human form are there for a reason and probably are an optimized structure and probably are important. And each of the structures of the human being that you decide not to put on your robot, if you want to mimic a human being, it's my guess that you're making a mistake not to put them on your robot. And this would include the joints, the proportions of the whole entire form, the joints, the way the joints work, the range of motion of the joints, and the axes of motions that are available. For example, on the knee, the axis of motion on the knee, there's only one axis. On the other hand, with the ankle or the foot, it has two axes of motion. It can move, it can do dorsal and plantar flexion of the foot, and it can also do eversion and inversion of the foot. You can see right here, see the amount of tilt that this leg has compared to this foot. And the only reason foot is flat on the floor is because the foot has everted itself a little bit. And my robot that I created, I gave it the same exact ranges of motion that human beings have. And I've not seen that in the rotary encoder robots. And I don't understand why they don't do that. And I think all of it matters. I put toes on my robots. They have a big toe. Oh, let's see. This is the left side. So that's the little toe. That's the big toe. That's the heel. It's not quite exactly what humans have, but it's close. And these are can be independently moved up and down by the central processing unit and by measuring the pressure in there and multiplying it times the surface area of this piston head, you can get how much weight each toe is supporting. So in this particular pose where we're back here at the back and this robot has got all of its weight on its right foot, by measuring the pressure or the weight distribution across these two toes, it can make sure that it's actually balanced over the foot. All of that's possible if you have toes that have a sensory capability and independent motion. None of that's possible if you don't have that. So I still am a little confused as to why they keep making human mimicking robots that don't mimic human beings. I'm not sure that's a good idea. And finally, I will mention, I believe all of this is possible. I believe that these robots could walk along. And this robot is walking in a way that you have never seen with a rotary encoder robot. And again, I keep saying, why don't they make a robot that mimics what a human being does? And they don't seem to. I think because it's not possible with rotary encoders. I did want to show how this walking works if you're going to imitate a human being. And I don't think it can be done in 15 minutes in a way that does it any justice. And so I'll do a series of 15-minute videos, and I make them 15 minutes so I can put them on on LinkedIn, but I also upload them to my YouTube channel. And I just took the sequence of walking and made it into 22 different poses, and then I rendered them, and then I stitched them together to make a movie to show the robot walking along. And that movie is on my website. You can download it for free. And you can go to discussions about a piston robot. And then piston robot discussions. Hi. And here is this robot walking along. That's how you can download this. Every time I see this, I just have trouble believing it. But I'll let you watch it walk just a little bit. And to me, that's a very natural looking walk. And I've never seen a rotary encoder robot that walks like that. And the question is, why? Why don't they do that? All right. So I will get into the secret signal here that I got to stop talking. So I will stop talking, and then I'll set up another part 2, and I will show you how this robot is walking along like a human being. Walk like a human, like that song says. And I have my little dots on here to make sure the robot stayed lined up like it was supposed to. And this is all on my website if you want to watch it.